Okay. Questions like this, I'm not going to call them fun. They might be fun for me, but they do definitely pose a challenge. I call these nested triangles. Anytime you've got more than one triangle visible with triangles inside of other triangles, I like to call them nested triangles, right? So I start by saying, well, how many triangles do you see? And hopefully you see we've got the one big right triangle here. And in fact, I'm just going to start drawing these as best as I can freehand. So we've got that one right triangle right there. We have this oblique triangle, right? We'll call that ABC. So we have this oblique triangle here. And then we also have a right triangle kind of nested into this corner. It's a little bit smaller, right? So we have three triangles. Um, when you see a nested triangle problem like this, and we're solving for H, right? We're solving for this. You always want to look at these triangles and see one of them is going to help us solve for H, probably more than one, right? But we're not always going to be able to just set up one equation to solve for that. Okay, so when you look at the information that we know, right, we know that this angle, which is right here, is 74 degrees. We know that this angle, let's color code this. We know that this angle is 49 degrees. We know that this length is 167. And then for the right triangle, we know that this is 49 degrees. We know that this is H, and that H is the same as this H, right? But when you look at the base of this, or one of the legs of this right triangle, we only know a piece of it up to a certain point is 176. So when you think about triangles, when you think about trigonometry, we've got let's call it three. We've got three ideas that we can work with that we've talked about, at least in pre-calc, right? You've got SOHCAHTOA, which is right triangle trigonometry. You've got unit circle trigonometry, which I don't think is going to apply here, right? Because we don't have any angles that we're used to seeing on the unit circle. And then we have the law sines and cosines. So when you think about those three approaches or methods of trigonometry, when we think to ourselves, well, if this is a right triangle, I can do SOHCAHTOA. We can only do SOHCAHTOA if we know two pieces of information about that triangle, right? We don't. We know one piece of information. We would need another side length here or here to be able to solve for H. Okay, and this is where we start to talk about all the other triangles. Okay, same idea here. We can't solve for H right now because we only know one angle and a piece of one of these sides. When we look at this oblique triangle over here, even though it's not labeled, okay, we do have angle B, which is right here, and we can figure out what B is because it has to be the supplement to to 74 degrees. So we know that this is 106 degrees. Now, when you look at this third triangle, okay, we have two angles and one side. I would say that's an angle side angle relationship that we have. Okay. And when you have angle side angle in any triangle, whether it's a right triangle or an oblique triangle like this, we can use the law of sines. Okay. And the key here is that if you want to find this side length, that side length is this, right? We're talking about this line right here. So that shared side between the oblique triangle and the right triangle. If I can find that side length from this oblique triangle, I'll be able to use that over here to then SOHCAHTOA this thing to get H, right? So that's the approach that we're going to take. Pardon the length of the math here. I'm going to have to kind of go up and down a little bit, right? But we have this side length. This is, let's label this the way that it's labeled, right? A, B, and C. So for the law of sines, we're always talking about wanting one complete ratio. Since we have this side length, we can figure out what this angle is, right? So add these together, we get 155. So we know that the measure of this angle right here is 25 degrees, right? Those angles have to add up to 180. So now I do have one complete ratio. 176 over the sine of 25 degrees is equal to, I'm looking for this side, so I'm going to use angle A. We'll call this side A right here, times the sine of 49, right? We have our proportion. We're going to cross multiply. A times the sine of 25 is equal to 176 sine of 49. And as I mentioned in class, we need to learn to see this as one single number, right? That trigonometric package represents one value, and that one value is being multiplied by a. And since we want to solve for a, we're going to divide by that singular value, which is the sine of 25. So here's our calculation that we're going to put into our Desmoser. You'll have to excuse this information here. So I've already forgotten it. 176 sine 49 over sine of 25. 314.299, blah, 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 blah. Let's go back and look because I kind of missed, I jumped over this part for Math Excel. Okay, it says round all intermediate values to the nearest tenth. Intermediate values are those values that we're solving for in the middle of the problem, right? Intermediate. So as we're using some of these outputs to then continue to solve the problem, they're saying it's okay to round to the nearest tenth. So when we look at our answer here, we'll call this 314.3. So coming back to it, we now know that A is approximately 314.3. And that A, just to remind everyone, is this side length, and that side length is the same as this side length, 314.3. So now, in terms of solving for h, so now we're looking at this right triangle and saying, well, I have an angle, I have a side, and I have this side, right? So when you look at this triangle, let's switch it up. Let's go to red. When we look at this triangle, we have this angle. We want to know what the opposite side is, and we know what the hypotenuse is. So opposite and hypotenuse, I can write a sine relationship. Sine of 74 is the opposite side over the hypotenuse. And then solving here, we're going to multiply 314.3 times both sides. So we get h is approximately, in the end, what do they want? Round the final answer to the nearest tenth as needed. So 314.3. 314.3 times the sine of 74. We'll call that 302.1. So h is approximately 302.1. I don't think there's units here. There's no units. There you go. So again, with these nested triangles, my approach, I draw them separately. I write down all the information that I actually know about them, and then I determine, am I going to be able to use SOHCAHTOA? Am I going to be able to use right triangle trig, or am I going to be able to use the law sines or cosines, right? Then piece together what you can from that. Find that shared side in these nested triangles. There's always going to be a shared side, right, that's cutting through the middle of the triangle here, right? That's usually the keystone. That's usually the most important piece to find, because it applies to two other triangles.